more titrations, but now we're narrowing our category down and just doing precipitation titrations. So we're adding, you know, some titrant, and it's reacting with the analyte in the beaker, but we're getting a solid. Okay, and it seems like you have to do a precipitation titration to analyze this story with silver and chloride and potato chips, and I don't know, just made up a story, right? That the guys were being sued, maybe some diabetic died or something, I don't know. I ate all your chips and I ate all this chloride, right? I don't know. There's a lot more sodium chloride in there than what you have on the label. My daddy died. So your job was to analyze and just see if actually they were right or not. And, right? Isn't this what scientists are supposed to say? You know, and you're all excited. Right? Eureka! Hey, boss, all's okay. Hopefully, that's what you get to say. Okay. So, our objective is there in blue. We want to find PAG+. PAG+. Well, what the heck, Randy, is PAG+? What's pH? Randy, what's pH? The equation for pH was negative log of concentration of hydrogen. So PAG+, Kimberly, must be negative log of Ag plus concentration. So that's all we're after. We're after the negative log of the Ag plus concentration. So instead of actually doing the experiment, you know, and dumping out a little bit of silver nitrate and then determining PAG+, right? You can actually do the experiment, but instead let's just theoretically calculate it out, right? And plot it out theoretically. And that's really all the goal is of this, is to create your own titration curve, theoretical, and plot it out. So that means there's going to be 3 parts. You're going to be starting out, right? And then you're going to be adding, and then you're going to be at VE, at the equivalence point, and then you're going to be after the equivalence point. So there's kind of 3 parts. There's before the equivalence point, at the equivalence point, and then after the equivalence point. So before, at, and after. So there's just 3 calculations that we need to know. And the calculation just depends on whether you're before, at, or after the equivalence point. And then we can plot out our own calibration curves. But we need to make sure we have the terminology down. Like, what did I call the stuff in the burette, Pedro? What did I call that stuff? The titrant. And then in the beaker, Miriam, the technical jargon was analyte. Okay, so that's something to remember. Okay, so it says 50 mils of 0.18 molar sodium sulfate is titrated with 0.85 molar silver nitrate. So John, which one is my titrant? Right, which one of these is the titrant? The Na2SO4? So the titrant's got to be the dude in the burette. He's the dude you're figuring out the volume of, right? Yeah, the AgNO3. Because I think there's a couple hints. When they say titrated with, whatever you're titrating with is your titrant. The other hint is, well, you have 50 mils of the sodium sulfate. So that's what they dumped in the beaker, right? Because that burette, I mean, you quit when you quit. There's no set volume on it. Okay, what's in the burette? But I'd say usually they say it always works. When you titrate with something, the with is what's in the burette. That's your titrant. That always works. Okay. So VE is the volume of titrant added at the equivalence point. That's what I call VE, and that's what the book calls VE. Let's start out, though, Danielle, with the reaction. We're adding some silver nitrate from the burette. It's supposed to react with sodium sulfate. We're supposed to get a precipitate. I don't know. What are the reactants? Let's start with that. Danielle, what would be my reactants? the Na2SO4 plus the AgNO3. Okay, there's my reactants. Miranda, what would be my products? Put the Na with the, not the Ag, the NO3. Sometimes I think it really helps, this is what I've been starting to do with my Gen Chem people, is just always write the charges up here. Life is so much easier. Because then it's so easy to combine what with what. And like the Ag and the NO3, do you remember the game? What's the charge on these guys have to be? Just looking at the formula. -1 and 1, the same. Right? Because look at those little subscripts. So if you put in the little charges, it's so much easier to see what I gotta combine. Oh, okay, I combine this cation with that anion with that, right? Cation. And if you keep the charges on there, it even tells you what the subscript's got to be. And I said the Ag with the SO4. Right? Notice how, hopefully now it's staring you in the face what's wrong. The 2 has to go where? Next to the Ag. Right? So if you put the little charges in there, and there's nothing wrong with writing them. They don't hurt anything. Just don't write a big plus in there. Right? I'm just talking about writing little charges up there. Okay. One of them has to be a solid. Which one? It's the silver one, right? Yeah. So everything else is going to be, you should put what subscript on? AQ. Aqueous. We should put aqueous on everything else. I guess we should balance the thing. We have 2 silvers, so we have to have 2 here. But now we have 2 nitrates, right? So now I screwed up the nitrates because now I have 2 nitrates, so I have to put a 2 over there. Now I have 2 sodiums, but I'm okay because I have 2 sodiums. Okay, so there's our equation. So we have that. Determine VE. We really don't need the reaction, but I think it helps to know what's going on. Right? We're dripping the silver nitrate in. It reacts with the sulfate to make silver sulfate. Okay, let's get VE. Pablo, where would you start to get VE? Where would you start? Now, what is VE? It's going to volume of the titrant. Exactly, volume of the silver nitrate. So we need mils of silver nitrate or liters of silver nitrate, something like that. How do you get it? Well, you could. Yeah, you could start. Well, you could, if you want to start out with him, remember what's big M? Moles over liters. So I probably wouldn't start with him like that. I'd probably flip them. You could flip them, right? You could start that way, right? Flip them. Because then you have liters up on top, and you just keep messing with stuff to cancel it. That's one way. That will work. The other way is that titration idea, the concept of it, that this volume of this stuff is chemically equivalent to this concentration of what volume, right? If you think of it, if you want to think of it that way, you want to start probably with 50 mils, okay? But there's nothing wrong with starting with flipping this guy. But to me, since there's a mole bridge thing going on here, I kind of like starting over here because I like the chemical equivalency idea. But if you want to start over here, that's fine. The units are going to tell you have to involve a mole bridge to get it. It doesn't really matter either way. But let's just start with the... this is how we did it last time. All right, we started with the 50 mils, which is 0.05 liters. Right? And that's of this stuff. Right? So in a liter, and I could just leave out the sodium. Right? I mean, I don't have to, but I kind of like leaving out the sodium because all I'm really interested in is the sulfate anyway. Because remember, you can write what do you call it when you break this up? What type of equation? This is the molecular equation. You break everything up, and you could write the, starts with an I, the ionic equation. Cancel common ions, and you get the net ionic equation. They're all the same. You get the same mathematical answers no matter what you use. So don't worry about it. We can keep it all in there. It really doesn't matter. Let's just keep it in there. We have 0.18 molar sodium sulfate. Even though the sodium's not doing anything, it's not hurting anything. That's the equation we wrote, so you might as well just stick with it. Right? Oh, not big M. Supposed to write MOL. Yeah. Okay. Mole of sodium sulfate. 2 moles of, which one am I interested in? The AgNO3. For once, something isn't 1-to-1. I need 1 of those for every 2 of those. Okay. Now, how do I get it into volume? Right? This big guy, right? 0.85 moles in a liter. Remember doing this? Yeah, now you're right. Now someone said milliliters. We should probably do milliliters because we're going to need it. You'll see why in a little bit. Okay. 0.05 times 0.18 times 2 divided by 0.85 times 1,000. I got 21.17 or so. 21.2. Okay. Now again, you didn't have to start this way. We could start with, see, you could have started with this one right here. Right? Start with this guy right here. We just ended up working backwards. It was the exact same problem but backwards. You recognize it? You would have wrote this one first. And then, well, you got to cancel the silver nitrate, so then you use the mole bridge. Then you got to get rid of the sodium sulfates, right? So it works. But I kind of, this way seems to make more sense to me since it's a titration. But okay, 21.2 mils is the equivalence point. So our first objective is to find PAG plus, the negative log of the silver concentration. Where? Find PAG plus where? In the, where? Where's this little probe at? Must be something. Some little probe that's measuring silver concentration. Where's the probe at? Yeah, it's in that beaker and where the analyte is, right? Because it wouldn't make any sense to have it in the burette because you know what that answer is. That's 0.85 molar. There's no precipitate there. It helps to know those bloody solubility rules because, right, nitrate with anything, does it ever make a precipitate? It doesn't. There's one other one. One other anion that doesn't make a precipitate with anything. Anyone remember what it is? Acetate. Acetate's the other one. So that's how you get these ions that love to form solids. That's how you get them in solution. That's how you get the little ions there. Combine them with acetate or nitrate. Okay? And then you've got the sodium sulfate. So what makes this thing soluble? It's the Na. Right? So to me, those are the only, honestly, the only solubility rules I know. If you get out of that, I have to go Google it. I know that sodium, lithium, potassium with anything is always soluble. I know that nitrate and acetates are always soluble. Anything else? Copper chloride? I don't have a freaking clue. I have to Google it. All right? I've always done it from the beginning. So how many years have I been doing this? I still don't know. But those two always work because you use them so often. Okay. We want to find the negative log of the silver ion concentration when we add 10 mils of titrant. Okay. So we're definitely, well, it says, we're definitely before VE, right? Because VE is 21. So we added some titrant. And the titrant was the AgNO3. You can just write that up there. Okay, so we added some titrant, some AgNO3. What's going to be the source of this silver ion that we're monitoring in that beaker? Right? Because doesn't it all react, right, when we add it? It all reacts, right? With the sulfate to make silver sulfate. So it's a KSP problem is all. Right? Let's skip down to the final answer here. It's going to be a KSP problem. Right? How do you write a KSP reaction? Yeah, but the solid is on the reactants or the product side? Reactant. Solid goes to its ions. So you end up writing Ag2SO4. I'm just skipping to the very end to let you know where we're going. 2Ag plus SO4 negative 2. Right? So this is where we're headed. And then KSP, we look it up. We'll have to. That's going to be the concentration of silver to what power? Squared times the concentration of the sulfate. Did everybody agree? And we'll look up the KSP number. This is the only source of silver ion. Because you dump in some silver from that burette, it immediately reacts. This is the only place silver ion is going to come from. So this is the only place you can calculate it from. So that means we have to know KSP and we have to know the sulfate concentration. And this equation is going to get us there. Right? This equation is going to get us there. So how is it going to do it? Now we started out with 50 mils of 0.18 molar sodium sulfate. Right? And we add some silver nitrate. Is the amount of sulfate going down? Right? Because you could figure the moles of sodium. You could figure the moles of sulfate. You add some silver ion, the sulfate, doesn't it react with it, right, to make the silver sulfate? But there's still some left, and that's all we're doing. We're going to figure out the amount, the fraction left. We're going to figure out the fraction left of the sulfate. Because we're before VE, there's still a bunch in there. Not all of it reacted to make the solid. And remember, the stuff that kicks out, just by this thing alone breaking up, isn't a whole lot, but we have a lot of this sulfate. Right? Look at that. We have 50 mils of 0.18 molar of the stuff. We had 1 drop of silver nitrate. I mean, right? A little bit of that sulfate's going to react, but we're still left with a lot of it. Okay, let's see how we get it. Now the analyte, I should put what in brackets here? The silver or the sulfate? The sulfate. Remember? Because for two ways you know that. One is it's the analyte, right? Because we said the analyte's in the beaker, and you also know I'm before VE. I have a lot of sulfate in there. I dumped a bunch in there, and we're just going to figure out the amount that's left over. So this equation, this relationship is going to get us the fraction left. We get that number, we put it in down here, and we solve for silver. That's all we're going to do. Okay. So we just got to understand the trick to get the concentration of sulfate left over. What is it? Well, it's first the fraction left. Okay. If we added, what do I mean by that? If we added VE, right? We got a beaker full of this sulfate. We keep adding silver until we hit VE, meaning we added just the right amount of silver to react with how much of the sulfate? All of it. That's the whole point of VE, right? It just reacted with all the sulfate. So when you hit VE, there's none left. There's none left. It's all solid. So when you want to get the fraction, right, that's the denominator, VE. Right? Are we halfway there? Are we all the way there? So if it, right, the fraction left. Okay. Well, Let me just show you, that might be easier. VE minus the 21 point, well, no, how should we add? 10, sorry, 10. Okay. So you put in the number for VE, right? Subtract how much you've added, divide it by VE, that's the fraction. Does that make sense? If you add, see how if you add VE, there's no fraction left, you get 0.
So VE is 21.2.
Yeah, VE is at 21.2, huh? Sorry. VE is the 21.2. So that's how you get the fraction left. Okay. Now, what was the original analyte? What's the analyte again? V sulfate. That's what's in the beaker. That's the terminology. So it's got to stick with it. We're stuck with it. What was the original sulfate concentration? 0.18. So you put that in. Okay. Now you have to take into account the dilution factor. We've done this a lot, but I don't know if you realize it. We did it in lab a gazillion times. It's kind of like that. What's the total volume? It's really just the original over the total is really all it is. That's the factor that you're diluting by. Because you keep adding silver, right? This stuff it's no longer 0.18 molar anymore because you added some silver, right? You added some volume. So the 0.18 molar is not right anymore. It's not right. You have to multiply it by some fraction, some dilution factor. Well, the original, right? Sorry. Oh yeah, we can do the original. The original volume was what? 50. Okay. Well, what's the total? 50 plus 10. Exactly. We've added 10. 50 plus 10. So that's going to be reducing our concentration a little bit. It has to. So that's how you get dilution factors. It's always what you started out with divided by the total. And that fraction is your dilution factor. Oh man, we got to do some math here. 21.2 minus 10 Did you get 0.079 about? Oh, good, thank you. Okay, 0.079 big M. After you've added 10 mils of the silver, our concentration of the sulfate was 0.18. But it's gone down. It has to go down because it reacts with the silver. So now it's 0.079. You could do a whole big ice table if you want, but remember when they tell us the concentration, we kind of just skipped it because there isn't any change. There's nothing really to do. We're not calculating solubility. So we just plug it in. We know what the sulfate is. Just put it in. Sulfur, silver. Oh, we need the KSP. Oh, I have to have it somewhere, don't I? Did I look it up? Silver. 1.48 times 10 to the negative 15. KSP is 1.48 times 10 to the negative 15 has to equal silver ion squared times that sulfate concentration. Which is this guy. Let's see. Divide him. Take the square root. I got about 1.37 times 10 to the negative 7. Did anybody else get that? Oh, good. Thank you, Anna. Okay. I haven't screwed up yet. That's good. There it is. Oh, that's not our answer. What do we have to do? Take negative. No, after you take square root, you'll get this. But they don't want the silver ion concentration. They want PAG+, because that's the convention of what you titrate. Okay, so take the negative log of it. About 6.86 is PAG+. Okay. That makes sense? So when you're before VE, this is the relationship you just got to remember, right? Okay, you get the concentration of what's in the beaker, what's left, by taking the fraction left, which is just use that VE, right? Because the VE, once you hit VE, you're totally there. So VE minus the amount you've added, divided by VE, that's the fraction, times the original concentration, but then times the dilution factor, because you're diluting the stuff by adding titrant. And that's always the original over the total. Okay? And then whatever you get, plug it into the KSP expression, because that's the only source of the metal, of the silver. And then when you're at VE, right, you've added, it's kind of like you put, VE minus 10 over VE. Now we're at VE, so it'd be VE minus VE over VE. Well, you just get 0. There's nothing left. So it's just a straight KSP problem. So, and if you're not sure what that means, just write it out. Ag2SO4 solid goes to 2 silvers and a sulfate. Right? So we have to get the concentration of silver, and once we get it, take negative log, and we'll have PAG+. So how do you get the concentration of silver? We need to do the one tool in our toolbox. I guess there's 2, right? Because sometimes we skipped ice, right? But we can't skip ice now because we don't know the concentration of the sulfate. So we're going to have to do ice, right? I guess we have 2 tools. But that's a solid, so don't put anything there. Anything there initially? We're right at VE. We're right at VE. That means there's nothing there initially. Every drop of silver ion reacted with the last drop of sulfate that was left. So nothing there. The change row, you'd put 2x and x. 2x and x. The reason why the darn 2 is important is because remember, here's all your answers. Once you get your x, how do you get the silver ion concentration? Yeah, we're going to use KSP to get our x, but then you go back. Silver ion concentration is 2x. So you got to remember to multiply your x times 2, because this is where all your answers are. You're right. So we have to use the KSP to get it. So KSP was over there. It was 1.48. 1.48 times 10 to the negative 15 is going to equal silver ion squared times sulfate. Okay. Well, that's going to be what squared times what? That would be 2x squared and my x. So we got to get our x. So we're going to have to take the 1.48 times 10 negative 15, divide it by 4, and then take the cube root. Yep. Divide it by 4, and take the cube root. There it is. 7.18 times 10 to the negative 6. Okay. But not my answer. Silver ion concentration is 2x. Not my answer. They want PAG+. So So multiply by 2 and then take negative log. Because here are all of our answers. X is the concentration of the sulfate. 2x is the concentration of the silver. That's why. .84. So you multiply your X times 2. Then you'll have your silver ion concentration. And then negative log of it. Okay.
So
Natalie.
difference between 2 and 3 is that the one was before and the other
At VE. Yep. So in the homework when they say, you have to, I guess the trick is to look at the darn volume. And if it matches VE, this is what you have to do. You have to do a straight KSP problem. If it's before VE, then you got to do that relationship that we just did. And if it's after VE, well, that's what's coming up down here. So you have to look at, a lot of the homework, sometimes it says when 1/2 VE has been added. Well, you just find out what VE is, multiply it by 1/2, and that's where you're at. Okay. I think the homework does that a lot, instead of writing down numbers. Okay. Notice how, we didn't write it, but it's about 14 times 10 to the negative 6. Before it was 10 to the negative 7. So it's getting more concentrated, the silver is. It should. Okay. We're getting slowly, not very much, but slowly. Okay. The last part is you are now 23 mils. You're after VE. Okay? So now you're just dumping in excess what? You're dumping it in. You're dumping in extra titrant, extra silver. So there's no KSP problem anymore. You just got to figure out how much silver you dumped in.
So do you just add that?
So, okay, let's see. What we're going to do, so the concentrate and the titrant in solution. So that's our silver. So once we get our answer here, we're going to use this little relationship. And once we get our answer, we just take the negative log of it and we're done. No KSP problem. Because it's beyond it. We've dumped in, it's all reacted. It's like, who cares if you have that lump of silver sulfate on the bottom? Our source of silver is really just what we added, the excess. And technically, there is a little dinky bit, 10 to the negative 6 or so, that's coming from the precipitate. But man, that's going to be nothing in comparison to this excess you dumped in. So don't worry about it. Okay. So the concentration of this silver, this extra silver that you just dumped in now, is the original titrant concentration, which we said was what? What's the original titrant to calculate? Remember where the titrant is? It's 0.85 molar. That's what's in the barrette. That's the concentration of the silver. All right, times the dilution factor, because it's not 0.85 molar. It's the stuff that's in the barrette is, but once it mixes in with what's there, it's not 0.85 molar anymore. It's going to be a lot less.
So is that 50 over 20?
So now it's,
Or 50?
and how do we?
50 over the 50 plus.
We're close. It's a dilution factor of the excess. So the total's on the bottom though still. Yeah. Let's do the volume. The excess, sorry. The total is what? 73, right? Because we had 50, we've dumped in 23, so we should probably write 50 plus 23, right? Okay. Now it's the dilution factor of the excess. So how do you get the excess? 23 minus VE, right? It's just the dilution factor. It's a dilution of the excess. It's not, because this is what you're interested in. It's just that little dinky bit that we added beyond VE. That's what you're diluting. It's not this whole thing. It's just a little dinky bit that goes beyond VE. That's what came from the Brett, and that's what we're diluting. That 0.85 molar and the little dinky bit that we added beyond VE. So, right, like VE minus, I don't know, the amount, or sorry, the amount added minus VE would look better, right? Okay. So, what is it, 23 minus 21.2. Then we'll get our concentration of our silver. And 23. Yeah, 0.021 though, right?
Yeah.
Okay. Yeah, 1.68. Oh, we're out of time. Okay. So there's more here for you to practice on, right? And then you have the homework. So have a good weekend.